Hello, welcome everyone. Hope you're ready to do some math today. So today we'll be
Yes.
covering. So we are gonna have fun, right, Ms. Chuka? So today we're covering
Yes.
inverses, matrices, and determinants of matrices, correct?
Yes. And if you haven't seen the link to go to 1324, it's on the chat. And I guess we'll get started. Okay. So, as Mr. Carizales says, we're going to be looking at inverses of matrices and determinants of matrices. And the big point of all of this is how do they relate to solving a system? That's one of the main priorities of why we use them. Okay, so let me go to the next slide. So just the definition of an inverse. Basically, something's going to be an inverse if you multiply the matrix times the inverse. It's going to give you the identity matrix. And if you multiply in the reverse way, the inverse times the matrix A, then it's and it gives you the identity, then we of each other. What is the identity? So the identity matrix is the matrix that has diagonals. One's in the diagonals and zero everywhere else. For example, this is a 2 by 2 identity matrix, and this is a 3 by 3 identity matrix. So notice the diagonal has ones, everywhere else is going to be zeros. So in WebAssign assignment, you have a question, or you might have a couple of questions that say, show that B is the inverse of A. So in order to do that, we need to multiply the matrices. So we're going to multiply A times B and see if we get I. And then we're going to multiply B times A to see if we get I. It's important that you multiply by switching the matrices. It's not enough to just multiply A times B, for example. You also have to do B times A. So last week we looked at multiplication of matrices. So for this example, I'm going to show you the steps, and then for the later, we're just going to refer back to it. So to multiply, you have to have the same order. So this is 2 by 2. This is 2 by, actually, you have to have the number of columns of the first one, and the number of rows have to be the same, which it is, 2 and 2. And so we can multiply. So we're going to take the first row times the first column. And here I put circles around the numbers that we're multiplying. So -1 times 1 gives me a -1. 2 times 1 gives me a +2. So then I have another column. So next we're going to use the same row and multiply the next column. So -1 times -2 is +2, and 2 times -1 is -2. I don't have any more columns, so I'm going to start over with the second row. So now we're going to look at the second row. -1 times 1 is -1. 1 times 1 is 1. And I move on to the next column. -1 times -2 is +2. 1 times -1 is -1. So we simplify. Then we get -1 plus 2 is 1. 2 minus 2 is 0. -1 plus 1 is 0. And 2 minus 1 is 1. So here we get the identity matrix. And so we might be tempted to say, okay, so I guess they're inverses of each other. But we cannot be sure unless we multiply B times A. And so here I just went ahead and did the work. And so you're going to see that we also get the identity matrix. So since they both produce the identity matrix, then we can say that B is the inverse of A, or vice versa, A is the inverse of B. If you have any questions at any time, please let us know, and we will pause so that we can answer those questions. Okay, so basically that is how we check if something is an inverse of each other. But the main part of the section is going to be how do we find that inverse? And there's multiple ways to do it. The first way on the left side is to write the matrix on the left side, and then you attach the identity matrix. Then you use row operations so that on the left side you end up with the identity matrix, and on the right side the remaining elements is what makes up the inverse. That's one way. And then the second way is to use a formula. So this would be your formula here. However, this formula only works for a 2 by 2 matrix. So if you have anything bigger, it's not going to work. So the formula is only good for a 2 by 2. Then another way is to solve the matrix equation times x, and I'll tell you what x means in a little bit, is equal to the identity, okay? And so the goal here would be to solve for x. So as you see the different examples, then you can decide which method you prefer. And so let me go to the first method. So this method here is ax equals to I. And the question is find the inverse. So to find the inverse, here's the matrix A that they give me. X is just going to be some numbers, right? We don't know what these numbers are. So I'm just going to call them x11. That means the 1, 1 means first row, first column, first row, second column, and so on. Again, these numbers in here, we don't know what they are. So that's why we're calling them X, okay? With the subscripts of their location. And then you have the identity. So I write it out this way. Then I'm going to multiply the A times the X. And so when we multiply, we would have 1 times x11 is x11. 4 times x21 is 4x21. And then I would go again 1 times x12, which is here, and 4 times x22. And then I would go to the second row, negative 1 times x11 gives me negative x11. And then negative 3 times x21 gives me negative 3x21. And last, negative 1 times x12 is right here. And negative 3 times x22 is right here. On the right side, your identity just stays the same. Okay. So what we're doing is we're actually creating a system that we're more familiar with. So if I look at the first two here, x11 and 4x21, and negative x11 and 3x21, I'm going to use that to create a system. So for the first one, I'm going to use the 1 because that goes with this position. And the second one, I'm going to use the 0. And so I put the 0 here. Then I'm going to use this part right here with the 0 to make this equation. And then this part of the equation with the 1 to make my second equation. So basically you have two systems now, and you can use anything from chapter 7 to solve for the variables. So I'm going to use the addition method. Notice here that we have x11 and negative x11. So if I add those two, I'm going to get 0. Okay, so they're going to cancel out or get 0. And then 4x21 minus 3x21 is going to give you a positive x21 because 4 minus 3 is just 1. And then 1 plus 0 is 1. So what I have done here is I've identified what x21 is. It's going to be 1. Okay, so now we're going to do the same. We're going to back substitute because we need to find out what x11 is. So if I back substitute, I'm going to use the first equation, x11 plus 4 times x21. x21 is just 1, and then equals to 1. So if I solve, subtract 4 on both sides, and we get that x11 is equal to negative 3. So now I know these two elements in the matrix, and I do the same thing with this right side. They're both, one is positive, one's negative, so I can just add them together to give me 0. And then 4 plus negative 3 will give me 1, and 0 plus 1 is going to give me 1. So I'm going to back substitute. I'll use the first equation, x12 plus 4 times 1 that we found here, and solve for x12. So we get negative 4. And so the variables that the elements that we found are these right here. So how do they look in a matrix? x11 is negative 3, so that goes here. x12 is negative 4, so that goes here. x21 is 1, so that goes here, and x2 is 1, so that would be your inverse. So the good thing is that we have 3 different methods. So if you don't like this method, then you're gonna hopefully like one of the other 2. I do have a preference, but I'm going to save to tell you what my preference is for after I show you the 3 methods. So again, the idea here is that we're taking a new situation and we're applying what we already know from a different chapter, which was chapter 7. So method number 2 is also bringing in what we learned in method number 1. Okay, so what we learned in section 4.1. So here, method number 2 means we're going to write your matrix A and attach the identity matrix. So it's going to look something like this. So here's my A, and here's my identity matrix. Okay. Then we're going to apply the row operations so that we have I, which is the identity matrix, and then whatever you get here would be your inverse. So in the identity matrix, we want to make sure that we have, let me just write something here really quick. So when we're done with this, we want to make sure that this looks like 1, 0, 0, 1, and then we're going to have some stuff here. Okay, that's what our goal is going to be. So since we already have a 1, then I really don't need to do anything for that part because I already have a 1. But I would like it to have a 0 on the bottom here. Okay. So the row operation I'm going to do is if I add 1 plus -1, I get a 0. So I'm going to add row 1 plus row 2. And whatever answer I get, I'm going to place it back into row 2. Okay, so 1 plus -1 would be 0. I'm going to write a 0 here. 4 plus -3 would be a 1, so I'm going to write a 1. 1 plus 0 would be a 1, and 0 plus 1 would be a 1. Okay, so this is what we would end up with. So let me repeat that again. 1 plus -1, 0. 4 plus -3, 1. 1 plus 0, 1. 0 plus 1, 1. Okay, so now remember last time Mr. Carizales says we always want to make sure to work the diagonal first. So this diagonal, we need it to be a 1, which it is. And so that makes us happy. So now whatever's on top and below, we need to make it into a 0. So in order to make it to a 0, we're going to multiply this 1 by a -4. Okay. And why do we want to multiply by a -4? Notice what happens here. -4 times 0 is 0, plus 1 would be 1. But when we come here, -4 times 1 would give us a -4. And then if you add a +4, it's going to give you that 0 that you want. Okay. And so here again, -4 times 0 is 0, plus 1 is going to be 1. -4 times 1 is -4, plus 4 is going to be 0. -4 times 1 is -4, plus 1, -3. And -4 times 1 is -4, plus 0, -4. So do we already have the identity matrix on the left side? Is this the identity matrix? Yes. Okay. So this is your identity matrix. This is I. And so whatever we have left here, that's going to be your A inverse. Okay. And so that's going to be your inverse. So notice this gives us the same answer that we had before. So if you're more comfortable using row operations, then you would use row operations, or you can do the previous method. I have a feeling that maybe the third method might be, some people's favorite. What do you think, Mr. Carizales? Do you think the third method is what your students like?
I think yes, but the problem is that they want to use that method for all sizes of matrix, and as you mentioned before, it only works with a 2x2 matrix, but they do like this method better than the other two.
Yes, so remember only 2x2. Once you have something bigger, then it's not going to work. Okay, so let's look at this method. So here for this method, it's using the formula. And so let's say you have a general matrix here and you have elements A, B, C, D. Then the formula tells you to we're going to have 1 divided by A times D. So you're going to multiply A times D. And then you're going to subtract the B times C. So you're multiplying A and D and B and C. And then you're going to switch. You're going to switch the A and the D. You're going to switch them, the positions. So now you're going to have D and A. And then for the B, you're going to change the sign. So this is a positive B. Now it's going to be a negative B. And this is a positive C. Now it's going to be a negative C. Okay, so that's how the formula works. This bottom part of the formula is actually called the determinant, which is something that we're going to be looking at later today from section 8.4. Okay, so the solution. So here I wrote the little A, B, C, D, just so that you can compare it to this matrix up here. And so the inverse is going to be equal to 1, or here's just the formula. I rewrote it. So let's plug in our numbers. So we're going to have 1. We're going to multiply 1 times negative 3 minus 4 times negative 1. I'm going to switch my A and the D. So I'm going to have negative 3, negative 1. The 4 is positive, so I change the sign. Now it's negative 4. And the 1 is negative, so I change the sign. It becomes a 1. So we simplify. 1 negative 3 is negative 3. 4 times negative 1, negative 4 times negative 1 is positive 4. And we're going to have 1 divided by 1, which is 1. And then once you have this 1, remember this is called a scalar. It's to multiply this number into everything in the parentheses. And in this case, 1 times everything here is just going to be itself. So my matrix, my inverse is going to be in red here, this matrix. And so notice that this method is a little bit quicker. But again, don't forget that it only works for a 2 by 2 matrix. Okay, so let's look at another example. I have 2 actually here. I'm going to use, it says any method, so I'm going to use the first method. The third method with the formula. So first we're going to substitute our values, right? So I have my 3 times the 2 and negative 1 times negative 2. Then we switch, the 3 and the 2 are going to switch. So now we have 2 and 3. And then the signs for B and C are going to switch. So now we're going to have 1 and 2. Simplify. 3 times 2 is 6. Negative 1 times negative 2 is positive 2. And 6 minus 2 is 4. So that's your scalar, 1/4. We're going to multiply everything by 1/4. And so now we're going to have 2/4, 1/4, 2/4, and 3/4. You can reduce the 2/4 is going to be the same as a half. And so I have a 2/4 here, becomes a half. Okay. Any questions on this example? Okay, so let's look at letter B. For letter B, we have the same thing. I'm going to use the formula 3 times 2 and negative 1 times negative 6. The 3 and the 2 switch positions, and the signs for 1 and 6 change. So we get 3 times 2 is 6. Negative 1 times negative 6 is positive 6. And 6 minus 6 is 0. So we cannot divide by 0, right? So we can't continue because of that 0. So we say that A is not invertible. So it doesn't have an inverse. Okay, so sometimes you'll have matrices that don't have inverses. And this is an example of one because you have a 0 in the denominator. Any questions on A or B? Okay, so then you get to something like this, right? Find the inverse. So can I use the formula? We cannot use the formula, right? Because it only works for a 2 by 2. So that means we are left with 2 of the other methods. And it gets a little long when you're trying to use the other two methods. And so normally, like in my classes, I like to test students without calculators for anything that's 2 by 2, but anything bigger, 3 by 3, 4 by 4, and so on, I let them use a calculator. But since I'm not sure how everybody else is doing it, I went ahead and wrote that how to do it by hand. So the first method is the AX equals I, okay? And so here, remember, you just have your matrix A, and then these numbers in here, we don't know what they are, so I'm just calling them X, okay? The subscripts 1, 1, 1, 2, 1, 3, those are just the position that they're in, and then we have the identity matrix here. What happen is we're gonna multiply this row by this column, and then this row by this column, and so on, okay? So it's gonna be, let me get the pencil out. So you're gonna have this row by this column, and then you're gonna multiply the same row, the blue, times this one, and then times this one. So that's gonna give you, once you're done with that, then you have to use the second row, and then you start over, right? So you go again here, here, oops, and here. And once you're done with that column, then you go to the third row, and you have to use each row again, okay? So how is this gonna look? And so I kind of multiplied it out already, but 1 times x1 is x11, negative 1 times x21 is negative x21, and 0 times x31 is 0. Okay, so if it helps, you can actually put, like if you don't want to get confused, you can put here plus 0 x3 if you want to. I just went ahead and left them out. And then we would go again, 1 times x12 is right here, negative 1 times x2 is right here, and then 0 times the third one is going to be 0. That's why there's nothing here. And then the third row, 1 times x13, and negative 1 times x23, and 0 times x33 is 0. And then we go to the second row, 1 times x1, 0 times x21, there's nothing there. And then negative 1 times x31 is going to be here. And so you just keep going until you're done, right? So you're going to have this system. Let me clean it up a little bit. And so from this system, then we can look at the first three. We can look at these three, which I put here in green. And then we can look at these for the second group, and then this would be the third group. Okay. Now these numbers here, the 1 and the 0 and the 0, that's just coming from 1, 0, 0, and then you have 0, 1, 0, 0, 1, 0, and 0, 0, 1 is your last one, 0, 0, 1. So then you're gonna solve this system. So I went ahead and did it only for the green one. So again, you wanna get rid of the x11s here. So before I can do that, I need to multiply this row by negative 1. So I end up with negative x11, negative and negative is positive x21, negative 1 times 1 is a negative 1. I didn't do anything to this row, so I just wrote it down. Now I can add them, so that becomes 0. I don't have an x21, so that's just going to be x21 here, minus x31, and negative 1 plus 0 is negative 1. Okay, so now the third equation, we also need to get rid of x11. So in order to get rid of x11, we're going to multiply by negative 6. Negative 6 times x11 is negative 6x1. Negative 6 times negative x21 is positive. And then negative 6 times 1 is negative 6. So I can add these two together. So this will cancel. Negative 2 plus 6 is 4x21. And then we have a negative 3x31, and then your negative 6. And so what happens is you have two new equations. I can write them out like this. And so we want to get rid of one of these. Let's get rid of the x2 once. And so to do that, I need to multiply by -4. That gives me -4x21. Negative is positive, and negative times -1 is +4. So I can add them. This will cancel, giving me x31 equals -2. So we can back substitute. So I have this one. I'm going to back substitute. I'm going to use this equation here. Let me highlight it for you here. x21 minus x31 equals -1. And so I know that x31 is a -2, so I plug it in. Negative is +2. Subtract the 2, so I get x21 is -3. And then for this one, I do the same thing. I'm going to substitute the 2 in here. So I end up with x11 is equal to -2. And so I have my 3 terms right here. And if I do let me go back. If I do the same process for the blue and the purple, then I will get the other columns that are right here. Okay. So as you can see, that process can be confusing, especially if we see a whole bunch of x1s and x2 ones and all that, right? But for some people, it's easy to see, but for others, we might need a different way. And so that different way is going to be to use the row operations, which means that you're attaching the identity matrix here. And your goal is going to be to have a 1, which we do. So everything below it, we need to make it a 0. So the first thing that we have here is we're going to multiply by -1 to row 1, and then we're going to add to row 2. So what's going on there is we're multiplying -1 times 1 is -1. Then we add it to this one, and that gives me a 0. And then -1 times -1 is +1. Add it to the 0, and then that's what we get here. Okay, 1. And so on. So -1 times 0 is 0 plus a -1, and then that's going to give us our next number. Let me erase that really quick. Okay, so we apply all the row operations. So we just do all the row operations so that we're left with 1s in the diagonal and 0s everywhere else. And so then whatever's left on the right side is going to be your inverse, which is the same answer that we got before. Okay. So my choice from this method, I'm like Mr. Carizales, from this method to this method, I prefer this method. Okay. Now your third method, which is, let me just share my screen really quick. That's only if you're allowed to use a calculator. Then you can put it into your calculator. Can you guys see my calculator? Okay. So you would enter on. And I guess I had already input it here. So when you enter your information, okay, you go to edit. You put the size of the matrix. You put all your elements in there. And then you quit. So if you want to find the inverse, you just call it. So here's my A. And then I'm going to use this key down here for the inverse right here. I click on it, and then there will be your answers there. Okay. But if you're not allowed to use a calculator, then it looks nice on paper as well, as somebody said. Okay, let me go back to the file. Let me see, right here. Let me just scroll down over here. It's faster this way. Okay, so let's go back. So so that was finding the inverse, but what is the purpose of finding the inverse and how can we use it? We can use the inverse to help us solve a system. And yes, you might be thinking, but we did that in chapter 7 and I thought I had a good idea how to use a substitution elimination. That's fine, but when you work with bigger systems, then using a computer is going to be helpful. And so you need to understand where they're getting all their information from and how the inverse is applied and so on. So in order to solve a system, this is going to be your, I guess you can say, your little formula to finding it. So we're going to have X. The capital X here is just a matrix that has variables, okay, which you'll see in a little bit. And then you have your inverse. This is your inverse. And then B is your constant matrix. And I'll explain that here in the next slide. Okay, so here it says use the inverse to solve the system. So here they already give you the inverse, so we don't have to find it. We just need to be able to use it. So here I have my matrix A. So my A is made up of coefficients. And so the coefficient of X here is 1, so I put a 1. The coefficient of Y here is -3, and then the coefficient of X is 3, and the coefficient of Y is -8. So if you use the inverse formula or any of the other methods, this is going to be your inverse right here, okay? They already did the work for us. And then B is your constant matrix. So these are my constants, the 4 and the 12, so I write it down. And then the matrix X is made up of your variables. So we have an X and we have a Y. So we have X and Y. So we use the formula. X is just your X and Y. The inverse, they already found it for us, which is -8, 3, -3, and 1. And then B is 4 and 12. So all we have to do is multiply these two matrices together. Okay, so remember -8 times 4 is -32, and 3 times 12 is 36. -3 times 4 is -12, and 1 times 12 is 12. -32 plus 36 is 4. -12 plus 12 is 0. So what this is telling us is that X is equal to 4 and Y is equal to 0. Okay? So yes, you always want to have the inverse on the left side of the constant matrix. Okay, so again, here it was cool. They already gave us the inverse, okay, but sometimes that doesn't happen. So for example, here it says solve the system using inverses. So we don't have inverse, we're gonna have to find it first. So I always tell my classes, identify all the matrices that are needed. So you need to have an A. So here's my A, is all the coefficients. You need to have your constant matrix, which is 27, 128, and then my X is X and Y. So I need the inverse, so I'm gonna go ahead and use the formula. 1 divided by 1 times -24 minus -5 times 5. And then I'm gonna switch the 1 and the 24 and change the sign. So -5 becomes +5, +5 becomes -5. Simplify. So -24 minus -25. And so here we get a plus, right? Negative is plus. So -24 plus 25 is a 1. So this is going to be my inverse, okay? So even after all that work, we haven't done the actual problem, right? All we did was find the inverse. So now we can plug it in to our formula. Here's my X. My inverse is what I just found here. And then my B. So we're going to multiply -24 times 27. 5 times 128. And then the next one, -5 times 27 and 1 times 128. Simplify. So we get -24 times 27 is -648. And then 5 times 128 is 640. Subtract, we get -8. And the bottom one gives us -7. So my solutions are X equals -8 and Y equals -7. Okay, so a question on that one. Okay, so so also another thing you can do with matrices is you can encode and decode messages. And so if you're trying to encode a message, let's say you're trying to say help, then you need to have an encoding matrix that only you and the person that is working with you knows. And so what you would do is you would multiply your encoding matrix times, maybe I should say, let's use the word cab really quick. That way we don't have to worry about the letters, right? So cab is letter C is not a one, it's the third letter in the alphabet, and letter A is the first letter in the alphabet, and then B is the second letter in the alphabet. So you would create a matrix. Let's say your matrix is, and I'm just making this up right now, a 2 by 2, okay? So then you can take your matrix 2, 3, 1, 4, and then you would create another matrix. And again, this is a 2 by 2. So whatever you put here has to be have 2 rows at least. So you can say 3, 1, and then 2. If you want a space, there's nothing here. You can use 27, because how many letters are in the alphabet? 26. So the extra space would be 27. Anyway, so you would multiply this out. Whatever numbers you get, so the first one is 6 plus 3 is 9. So you would put them here. I'm just going to make these up. 14 and 15 and 30, 35. And then you would, in order for them to decode the message, they would have to take the inverse of this matrix and then multiply it times these numbers. And then it would give them the 312, and then they can decipher what the message is. Okay. So you can use it in my class for my students. There is, in the video I created for them, they do have to, there's an example of that, and there's like an extra credit for them to decode a message that I sent to them. But anyways, that's how you would do that. Okay. So use the inverse to solve the next problem. So the good thing is that they already give us the inverse, so we don't have to find it. So all we have to do is figure out what A is. Again, it's all your coefficients. B is your constants, 0, 6, and 3. And then X is going to be X, Y, and Z. If we use the formula, we have the inverse, which they gave me here. Okay. And then I have my B, and then my, and this is what I'm trying to find, right? So to get these numbers, we're multiplying 1 times 0 is 0, 1 times 6 is 6, and negative 1 times 3 is 3. So if we add, we get a 3. And then negative 3 times 0 is 0, 2 times 6 is 12, plus 1 times 3 is negative 3. So then we get the 9, and then 3 times 0 is 0. Negative 18 plus 6 gives us negative 12. So my answers here are X equals 3, Y equals 9, and Z equals negative 12. So again, here you didn't have to find it because it's already there. Any questions on inverses? Okay. The determinant, we kind of already did it without us really knowing that we've been doing it. But remember in the inverse, when you have the formula, I lost my pencil. Okay, when you have the formula for the inverse, remember that you had 1 divided by AD minus BC. Then this is your determinant here. Okay. So here you have your matrix A. There's different ways to write the symbol for determinant. You can write DT parentheses A, or you can write the absolute value sign here, the 2 vertical lines with the A. And then to show that you're finding the determinant, notice that instead of a bracket, it's just a vertical line. Okay. And then we're going to multiply A1 times B2. And then we're going to subtract and then multiply A2 times B1. Okay. So that's how we would find the determinant. It's always going to be a number. So if you get a variable or something, then you know that you did it wrong unless your matrix has variables in it. But so if we look at A, okay, so I'm gonna find the determinant. So I change it. I wrote DT parentheses A. I changed my brackets to vertical lines here. So I'm gonna multiply 2 times 2 and negative 3 times 1. So 2 times 2 is 4, negative 1 times 3 is positive 3, plus the 4 is 7. So my answer is 7. Go ahead and try B and C. I'll give you a second to try B and C. And if you find the answer for B, just put it in the chat. And then we'll check them once we work it out. Okay, so for letter B, we would multiply 2 times 2 and 1 times 4. So 2 times 2 is 4, minus 4 times 1 is 4, so 4 minus 4 is 0. Letter C, I went too far. We have 0 times 4 is 0, and 3 halves times 2, negative 3, and so my answer would be negative 3. So if your determinant is equal to 0, then that tells you that your matrix won't have an inverse. Okay. So if your determinant is 0, like in this case, that means that this matrix will not have 0. I mean, will not have an inverse. So for 2 by 2, it doesn't seem too bad, and then we get to 3 by 3, right? So I'm going to explain this definition with the example, and then I'll use these cofactors with the example. That way it's a little bit more clear. So if you want to find the determinant here, then the first thing we need to do is find all the minors, okay? The minors are going to be done the following way. If I start with 0 here, and I cross out the row that it's in, and I cross out the column that it's in, then notice that I'm left with a 2 by 2 in here. And so I would find the determinant for this 2 by 2 that is left over. So the determinant for that is negative 1 times 1 and 2 times 0. So negative 1 times 1 is negative 1. This is 0, so my answer is negative 1. That's not your determinant, but it's going to get us there. That's what we call the minor. And then we go on to the next number. Let's look at the 2. So we would cross out the row and the column that it's in. And then notice it's always going to leave us with, now I have a 3 and a 4 and a 2 and a 1. So I make that 2 by 2 matrix. 3 times 1 is 3. 2 times 4 is 8. And so 3 minus 8 is going to be negative 5. And then I keep going. With the 1, I cross this out. I'm left with this matrix here. 3 times 0 and 4 negative 1 is 4. And we do it with each number, right? So now I'm going to go down to the 3. I cross out the row and column that it's in. And notice that the 3 is located in the second row, first column. So that's why I wrote this as 2, 1. And then I'm left with 2, 1, 0, 1. So that matrix is a 2. And you keep doing that with the rest of your numbers. So here I did this one as well. And then eventually you get all 6, right? Or all 9 of them. So I have all my minors. So your next step is once you have these minors, then you need to find the cofactors, okay? So to find the cofactors, we're going to take this that I had in the definition, which is the signs for each of the locations. And all we're going to do is we're going to take that minor times that sign. And so a negative times a positive is still going to be a -1. So I'm going to call this C11 so that I know that it's my cofactor. In other words, I know that I already multiplied this times this. Okay, then I go to the next one. -5 times a negative is going to be a +5. And then I go to the next one. 4 times a positive is going to be a +4. 2 times a negative is going to be a -2. And so on. Okay, so then I have all the rest here. And so now we're just going to work with the cofactors with these guys here. So to get your answer, we're going to take the sum of all the entries in any row. You can pick any row, so you can look at these right here, or you can look at these right here, or these down here. It doesn't matter which one you pick. And what we're going to do with them is we're going to sum them, and we're going to multiply by their respective cofactors. So what that means is now we're ready to find the determinant. So I'm going to take, let's say, this row here. Okay, so we have 0. We have 0 times the cofactor of -1, cofactor here, plus 2 times my cofactor of 5, and 1 times my cofactor of 4. If I add them all together, I get 14. But I also did it for the second and the third row, and notice that you still get the same number, 14. So no matter which row you choose, if you choose this row, or this row, you're always going to end up with the same answer. So you just need to do it once. I did it all 3 times just to illustrate it, but you just need to do it once. Okay. Or if you're allowed to use the calculator, then in the calculator, you would do it this way really quick. Let me show you really quick. In the calculator, let me clear my screen. You would go second matrix, and then we're going to do some math, and it's the first option, determinant, so enter, and then second matrix, A, and enter. So we get 1, okay? And so this was a different problem, but that's the idea. So maybe more than just one button, maybe a couple of buttons, but it gives you the answer right away. And if you have a graphing calculator like the one I showed you, it doesn't matter. You can also online in the computer online, you can find a graph calculator to help you do that. In Desmos, it helps you do that. And I think last week I put a link with a video on how to use those calculators as well. So let me see, I think we were on like 80 something for the slide. So let me keep going down. That way it's faster. Okay, so that was an example of that. Okay, let me go back. So we're almost done. So what is the point of the determinant, right? So you might be asking yourself that question. Well, we can also use it to solve a system. So let's say this is my system. In order to solve the system, you're going to need certain things. You're going to need your coefficient matrix. Again, the coefficient matrix is all your coefficients, the numbers in front of the x and y. And then we're going to find the determinant of that coefficient matrix. And then you're also going to need a constant matrix. So maybe here I needed to add, let me just add it really quick. Let's call it a C. This is your constants, C1 and C2. Okay, so those are your constants right here. And then we're going to form a new determinant, which is dx. And so since it has an x here, we get rid of the x coefficients and we replace them by the constants. So that's where the C1 and the C2 are. And then for the y, we're going to get rid of the y coefficients and then we're going to replace them with the constants. To get our answers, we take the determinant of the dx divided by the determinant and dy divided by d. So how does that work? Here's my system. I'm just going to gather everything that I need. So these are the things that I need to use. And so here's my coefficient matrix, 4, -2, and 3, and -5. I need to find the determinant of this matrix. And so 4 times -5 is -20, and then -2 times 3 is -6, and negative is +6, so we get a -14. And then I need to find dx. So be careful here. Remember the dx, you take away the x's. So instead of 4 and 3, we're going to replace them with our constants, which is 10 and 11. So that's where I get 10 and 11. The coefficients of y's remain here. So I find the determinant, 10 times -5 and -2 times 11 gives me -28. And then we're going to need dy. So remember, for dy, the coefficients of y we get rid of, and we replace them with the constants. 4 times 11 is 44. 10 times 3 is 30. So we end up with 14. So even after all that work, we're not quite done, right? So we need to actually find the answer, which is given by this right here. So we know that dx is -28 and d was -14. So -28 divided by -14 gives me a +2. And then dy is 14 divided by d, which is -14, gives me a -1. So my answer is 2 and -1. Okay. So those are some ways to use the inverse and the determinants. And so if you would like to see more examples, I know some of you have my YouTube channel. I have the whole the whole lecture on these two sections. Make sure to sign in. I don't know if somebody put the sign-in sheet already. Let me see. If not, let me put it in for you guys really quick. So this is the sign-in sheet for today. Okay. So next week, we're planning to basically review for the final. And so one of the things that Mr. Carizales and I will do is we'll try to find like the harder type questions. But I do encourage you to send any questions you might have to this email address. Let me make sure I have the right address. Give me a second. That way, if there's a specific question that you want for us to cover, then we can do that. Okay, this is my other email. So you can email me at mathprograms@ipcc.edu, and you can just say something like, next week, can you cover chapter 2 quadratic equations or something? And then we'll look at them and cover your question that was asked. Okay, but what I'm gonna do, and I'll talk to Mr. Carizales, is in my website I have a review that I give my students. So I might just go through those questions and make that the review. But I want to make sure that if there's a specific question that you want to see, that we cover that for you. Any questions? So if you get a determinant that is 0, so Mr. John Peter says if that the instruction says if possible, and so remember, if the main determinant of your coefficient matrix is 0, then we would run into problems here, right? Because we can divide by 0, and so that would be the instance where we're not going to be able to do that. And it could be that the system is inconsistent. Okay, any questions, other questions? Oh, Mr. Carizales and I, at 4, we have a meeting. We'll be here for another 4 minutes, but we do have some of our excellent tutors waiting in case some of you have questions. Please feel free to request a tutor. And the good thing about that is it could be a one-to-one thing or it could be together. It doesn't matter. But if you request a tutor, they'll put you in a room with that tutor, and you can ask any questions that you have. And don't forget to sign in.
Alrighty. I would like to thank Ms. Chica and Mr. Carrizales for presenting today, and also to you guys for attending and being such a wonderful audience. We hope to see you guys soon again, okay? Have a good weekend. And let us know if you guys have any questions. I will stop the recording now.